Mars studying the flight of a bird from its nest and he measures the bird's height above the ground, h meters at a time t seconds for 10 different values of t. And he finds the equation of the regression line for the data to be this here. So he's tried to fit a straight line to this data. Well, actually, it was 38.6. I don't know exactly what that's going to look like. Maybe something like this. So look, it's not looking a great fit from the very beginning because of the shape of the curve, but something like that. We're asked to interpret the gradient of the line. So I just wrote down that it was what did I write down? The height increase per second. And I think I'd be absolutely okay with that. The answers, they expand on it slightly. They say that the height, a bit more practical, decreases by 1.28 meters every second. I mean, those two are equivalent, but that's what it says in the answers. It even allows, if you accidentally said it decreases by minus 1.28, then you'd be okay. But technically, we need to say increases by minus 1.28, decreases by 1.28. Next up, we're told that the product moment correlation between h and t is minus 0.510, and we're asked to test whether or not there's evidence of a negative correlation between the heights above the ground and the time during the flight. Remember, there is negative correlation, but this is just in our sample, whereas our hypothesis test is saying, like, is there enough evidence to say there's actually this negative correlation for the entire population, like all the values of the height against time, like if there were like loads more. Um, so right, let's get into this. We need to state our hypotheses clearly. So H naught is that rho is equal to 0, that there is actually no correlation. We use rho because this is the sample correlation coefficient rather than R, which is the population one. H1, because we're seeking for whether there's evidence for negative correlation, then this is going to be rho is less than 0. And things are pretty much now set up because we can just quote the critical value. So we've got a 5% significance level. We've got 10 values of t, and you can look in the formula book for your critical values. Let me do it down here. This is a one-tailed test, so you'd have to have it if it was a two-tailed test. But we've got n is 10. We're looking at 5%, so we're going to be going down and along, and we're going to get to here. So that 0.5494 is my critical value. 0.5494. Just going to draw a little number line. So I've got -1 here. I'll put 0 here and 1 here. So we've just said that the critical value is here. But we've also got that the correlation was actually minus 0.510, which is slightly more positive. So actually, I'm going to write down that minus 0.510 it's not in the critical region. It's not sufficiently negative. This is greater than minus 0.5494. Let me just really like that there is the critical region, CR. And so actually, I'm going to not reject H naught. You get away with saying accept, but really you should be saying do not reject. There's just not enough evidence. We maybe need to look at more values or whatever. Although we can see in this case that, yeah, it doesn't look like it's fitting a straight line. Do not reject H naught. Insufficient evidence. At the 5% level, that there is negative correlation in the population. Brilliant. Jane draws the following scatter graphs for Mars data. Now, I have actually referenced it earlier. It's in the question. You can always like have a little look at it, even though in theory, we would have done that first question without it, but we've kind of talked about why it's not actually not going to be a good fit. So with reference to the scatter diagram, giving a reason whether or not this regression line is an appropriate model. And I said that it wasn't because it does not look like a straight line, does it? So as long as you say something like it's appears to be more of a non-linear curve, then you'll be okay. I'll just share the answers. They say, yeah, it could follow a curve or a quadratic, non-linear, but regression line is like a linear fit. Height drops by more than 2.56, you could say, between t is 5 and 7. It's just that the average is that it's going down by 1.28. Gradient's positive, that's something you could say, or it's positive initially, it's positive then negative. Words to, some words along those lines would just basically say that it's not going to be an appropriate model. Okay, Jane suggests an improved model using this variable. This is going to turn it into a parabola actually. K is a constant. She obtains this equation. So H is going to equal 38.1 minus 0.78 T minus K squared. So this is actually a quadratic, H in terms of T, because it's got to have a T squared in it, and it's in completed square form. So we're asked to choose a suitable value for K to write Jane's improved model. When something's in completed square form like this, we actually get the maximum straight away. We know it's going to be a maximum because it's a negative quadratic, and the maximum value is going to be, according to our model, 38.1. It's going to be when t is equal to k, because then this term would disappear. Otherwise, we're always subtracting from 38.1. So we just have a look at the graph. It looks like it hits its maximum around about 4. So that means that k is going to equal 4. As long as you give a value of k between 3 and 4.5, that was the sort of accepted region, and you'll be okay here. Well done.